198. Does it say 196? I thought I changed it. It might not have changed on yours. It might only have changed on mine. Yeah, Kelsey, if you already know how to do it, you can skip it. This shouldn't be a long stream at all. But you are doing page 198 in the workbook. Yeah, I thought I changed it, but maybe it only changes on mine after I post it, so it's 198. 196 was yesterday, I think. Yeah, yesterday was 196. This is stupid easy. You're just multiplying or dividing by 100, which means you're moving decimal points. That's all it is. No. Yeah, we probably did it on Friday. We are doing page 198 right here. This is today. Yesterday was 4/6/2020. You did workbook page 196. Today is 4/7/2020. You are doing workbook page 198. And yeah, this is gonna be a quick day. It's not hard at all. But yeah, we'll look at a few examples and see what you can do. Alright, I'll get started. Today we are looking at going from percents to decimals. Remember, percents, fractions, and decimals are all different representations of the same number. They're just different ways to write numbers. So percents to decimals is today, and remember our definition of a percent. Percent is a part of 100. So we're dealing with this 100 again. Do you have questions on it? I mean, I haven't looked at it because I set it to be due on Wednesday for some people, so they haven't done it. But if you have questions on 196, I can do some. We're going to be doing percents to decimals today. So anyways, percents to decimals, they're parts of 100. So all what you're really doing is you're taking that percent. So let's say, for example, we have 5%. Now I want to write it as a decimal. I'm going to divide this by 100. Because again, as a fraction, it would be 5 divided by 100. So I'm just going to divide it by 100. So 5% divided by 100 is going to just move that decimal point 2 places. So if I wrote the 5, the decimal point is here, divided by 100 is going to do it once, twice. New decimal point is there, so your answer is 0.05. Yeah, after I do a few examples, we can do number 17. Not too difficult. But again, if you had 22% or something, just divide it by 100. Again, that would be 22. Decimal here, you just move it twice, once, twice, equals 0.22. If you had 153%, just divide it by 100. Your decimal point is here, move it twice, once, twice, it's there now, 1.53 as the decimal. Note that this is more than 100% and this number is more than 1, because again 100% equals 1. Sometimes you have decimals as percents, so maybe you have this percent. Again, you can do the same thing you've been doing, you just divide it by 100, which is going to move that decimal point 2 places, once, twice, goes there, equals 0.002. You should keep in mind that your percent number is always going to be larger than your decimal number, by a factor of 100 actually, because that's what you're doing, you're dividing by 100. And that's all there is to it. So this is for the first set, I think. Yeah, so on this page here, this was yesterday's work. On this page here, this is how you do 1 through 12. You're just moving a decimal point. And then the other set is, what is it, 13 through 24, is just going backwards. So you're just doing the same thing, only it's in reverse. So let's look at some examples of that. Leave that arrow. So if I give you a decimal, such as 0.31, and there's a decimal, to make that a percent, you do the inverse. So we were dividing by 100 here, you're going to multiply by 100. So you just multiply that by 100, and in doing so on this one, 0.31, just moves your decimal in the other direction to there, and that equals 31%. Don't forget percent signs. Those are like your units. Yeah, I'll go over 22. Other ones, if you have numbers greater than 1, you still just multiply by 100, and it still just moves that decimal point 2 places, once, twice, 123%, and that makes sense because this is greater than 1, so this has to be greater than 100. Another example, sometimes you're given 0.006. Again, doesn't matter what this number is, just multiply it by 100 and you'll get the percent. It's going to move the decimal point once, twice, always 2 times, equals 0.6%. So it's always just moving it 2 times. And that's pretty much what your homework's going to be. Don't forget to do the other ones too. They're just kind of applying this to a word problem. Was that 15, 16? No. 25 through 27. Don't forget to do this too. Do the whole page. You can work on that for a bit while I'm on here. I'm going to go over 22 and 23 with Catherine, or if you have questions. But that's really all it is. It's moving decimal points. If you're going toward a percent sign, a little pneumatic to help you. If you're going from a decimal toward a percent, your decimal point moves in this direction. If you're going from a percent to a decimal, your point goes in this direction. So even maybe if you just want to write it as decimal to percent, you're going to have to remember what order they're in. But if you're going towards a percent, then you move it towards the percent sign. You see how I want to make this number a percent? Well, it doesn't have a percent sign, so I got to move the decimal point towards the percent sign, then I put in the percent sign. If I want to get away from the percent, I move the decimal to the left, away from the percent sign. Or you can just remember if you're multiplying or dividing. Multiplying by 100 is going to make your number larger. Dividing by 100 is going to make your number smaller. But yeah, that's all it is moving decimal points today. But let's look at yesterday's, was it 22? from page 196. Let me find the problem here. 22. In a survey, 23 out of 50 students chose blue as their favorite color. So off to the side here, I'm just going to write some notes down. 23 out of 50 fave color equals blue. What percent of students did not choose blue as their favorite color? Well, first off, if you want to make this into a percent right away, that's one way of doing this. There's a couple different avenues you could take this problem. But if this is how many people chose blue as a favorite color, I want to know how many does not like blue, so to speak. So how many don't like blue? So if 23 out of 50 like blue, then the remaining part don't like blue. Those cases are what's called mutually exclusive. You can be one or the other. Your either favorite color is blue or your favorite color is not blue. And that holds true for every single person on this planet due to the definition of what favorite means. But yeah, you can either favorite color is blue or favorite color is not blue. It's one or the other. So it is mutually exclusive. So if there are 50 people total and 23 of them like blue, the remaining remaining amount don't like blue. So you can probably do that in your head. I don't know why I'm doing this the long way. But what is that? 7 and 27 people don't like blue. And then you want to know what percent that is. Well, there's still 27 out of 50. You just want this to have a denominator of 100 for a percent. So you multiply that by 2, multiply this by 2, and you get 7 times 2, so 14, 4, 5, 54. 54 out of 100, which means it's 54%. And that's number 22. Again, recognizing that 23 out of 50 like blue, and it's asking you for the opposite of that, or the inverse of it. You can go that way. I guess the other way to do it is to make this a percent. So 23 out of 50 is equal to what percent? Again, times 2 times 2. Is that what, 46? 46. Yeah, so 46. So 46% out of them, 46% like blue. And then you can subtract that from 100, and you can get your 54% don't like blue. So you can do it that way too, if you want to work with the percents. Hopefully that clears it up for you, Catherine. We'll look at 23. Let's see. This is 23 from page 196. See, explain how you decide what number to multiply the numerator and denominator by when you convert a fraction to a percent. So if I'm taking a percent or a fraction, like, I don't know, 1/2, and I'm making that into a percent, where do I get the number that I multiply by? How do I know this number here? You get that number by honestly taking 100 and dividing your denominator. Right? 100 divided by 2 equals 50, so I'm going to multiply this by 50 and multiply this by 50. So it's just 100 divided by your denominator. How many times does your denominator divide 100? That's going to be true for all of these. So if you had, I don't know, 4/5, you want it as a 5 times what? It gives you 100. You can do it that way, or you can set it up algebraically, honestly. 5 times x equals 100. Right, divide that by 5, divide that by 5. Here's your 100 divided by your divisor. And you get x equals 20. So this would be times 20, this would be times 20. You get 80%. So there's different explanations for it. But yeah, you're pretty much just making your fraction with a common denominator. Of 100. So you're rewriting your fraction with a denominator of 100. So any one of those explanations could work for you, Catherine. Anybody have any questions about today's assignment at all? Any more questions about yesterday's assignment? Again, it really shouldn't take you long at all to do this. Which is, sorry, I just hit my mic. Hope that didn't bother you too much. Which is the best method for all the types of transferring between percents, decimals, and fractions? That's going to vary depending on what your number is, Eli. It's whatever you're more comfortable with. They tend to all work. I mean, if you're given a number that you already know, like 3/5, then you can probably do that in your head. If you want to make a proportion out of it, go right ahead. Right, 300 equals 3 times 5. I'm sorry, that's not what we're doing there. 300, because 3 times 100 equals 5 times your percent, whatever your percent is. I'm using the percent as a variable here, which might be a little confusing. 5 by 5 divided by 5, and you get 60. 60 is your percent. You can always do it that way. A lot of times for doing it, it's easy to hit the decimal first. Like if you're doing 136% and you want that as a fraction, well, the fraction is pretty easy, but the decimal is pretty easy too. Right? And then you can make that into a fraction and reduce however you want to reduce that. But yeah, it's whatever you're more comfortable with at the time. And it's going to depend on the numbers, Eli. Sorry, that's not the greatest answer for you. I will be giving you some pretty easy templates to use for things. So I will, when it gets to the other problems, if you've been looking in the notes for what's coming up, and again, we're going to hit up that after our break. I just need you to get good at converting between decimals and percents and fractions, because we don't ever actually use the percent in like formulas and stuff. So for example, if you're doing compound interest or something, which is what 7th grade was working on today, your formula is that, in your rates would be your like percent or something. N equals 3. You don't use this. You can't plug in 5 for that. You have to turn this into a decimal. So you have to use this number instead whenever you solve compound interest problems. So a lot of times we get away from the percent. We don't like it as a percent. But some cases having the percent is easy. Like, hey, it's 25% off. That's pretty easy to figure out. Hey, you should be leaving a tip of 20%. That's pretty easy to figure out. Which page, Catherine? Is that page 198? and you want to write this as a percent, you just do the inverse. Right, so in this case, you move your decimal once, twice this way. You're just moving the decimal the other way. But don't forget your percent sign on those ones. Those ones have a unit. Because 20% does not equal 20. That's not correct. That's good. If you have questions, ask. I can hang on for a couple minutes, but if you know what you're doing, you don't have to stick around. Yeah, get that page done by Wednesday, probably. I'm not going to be looking at any of them by Wednesday because I have some people who are having some issues this week. So I'm not going to hold the grade against anybody until then. Just keep up with it. Do I plan on giving you something tomorrow? I think I do. Yeah, you'll have page 200 tomorrow. If you want to look at it now, it's fine. But again, it's not too difficult. It's all really the same kind of stuff. Yeah, it's just going to tell you to write as both a fraction and decimal. And then it's going to ask you to order some things, which if you can order decimals or fractions, you should be fine. Yeah, that way you should probably be able to finish that tomorrow in class. I mean, then you don't have anything in math to work on over break. 25? That's the first word problem or something, isn't it? 25 says 2 candidates run for class president. After all the ballots are counted, one candidate has 50% of the votes. So one candidate has 50% votes. What decimal names the portion of the votes the second candidate has? Second candidate has how many? So if candidate 1 has 50% of the votes, candidate 2 has what percent? This is one of those examples of poorly written questions, because these scenarios, they're expecting you to think that this is mutually exclusive, but it's not. I mean, there's never just 2 candidates in a race. You could just write someone else's name in. So technically there's going to be a margin of error in all this anyways. But if 100% of the votes were cast and candidate A had 50 of them, how many did candidate B have? I guess that's a percent too. It wants you to know that. Just converting this into decimals, 100 as a decimal is 1. 50 as a decimal is half, right? Plus x. Same problem, just in decimal form. And then you can solve for x, which hopefully you realize is 50. Like if this person here has half the votes and this person here also has half the votes. But I can show you the math for it, right? Subtract 0.5, subtract 0.5. You're left with 0.5 equals x. So they had 0.5. I don't know why it wants it as a decimal. Yeah, well, that's what it is. It wants it as this, and it wants you to explain why this is it is, and you could write this. This is your explanation. Hey, if you want to put it in words, you can. All the votes equal 100%. Candidate A got 50%, meaning candidate B got the remaining 50%, and 50% as a decimal is 0.5. There, if you want in horrible sentence form. But again, this here is a good enough explanation for me too, if you know what's going on there. Yeah, if you don't have any other questions, I mean, if you're good with that, you can go for it. I mean, again, I really didn't think it was that difficult. This week I'm trying to keep it pretty easy because, again, I want you to have these skills pretty much down for next week. Because I don't want to sit here and explain every time I take a percent and make it a decimal how to do it, or every time I take a fraction and make it a percent how I do it. I need you to know that. Because it's just going to be happening a lot. Because honestly, we just don't really work with percents a lot. They're easy to do in your head, that's why we use them, but when you get to the difficult percents, you can't do them in your head that often, so you find other ways around it, make them decimals and fractions. But if there are no other questions, I'm going to let you guys go. Finish up page 198. So page 198 in your workbook. Even if you didn't finish page 196, do that. And if you're brave, you can go on to page 200 because that's going to be tomorrow's assignment. So if you have any other questions, shoot me an email and I'll put a response together for you. And with that, I'll let you guys go. I think it stopped raining, so you should spend some time outside away from other people. Just, get some exercise in. And I will talk to you later. Bye.